All right. There was another one that got 15 likes, which is wow. I'm archiving this, so it's gone. Because we covered that already in Q&A session with Datsa, I think, at least partly. So thanks for being so active and so provocative. That's, I think, part of the deal when we analyze something, invent something, discuss something, and make decisions about. All right, we have now concluded the keynote session. Are you okay, by the way, because the break is just 1 hour away from this moment? Okay. Caterers asked me, like, they said 2.5 hours they were going to be sitting there. I mean, it's just so long. I said, well, it's going to be very active and dynamic, you know. All right, so let's kick off the session 1. Greenhouse gases emission factors, methodologies, and results. We have 4 speakers, same thing basically. Presentation, slide of questions, presentation, slide of questions, and so forth. All right, so our next speaker, Andreas, he is expert in peatland restoration and sustainable use. So please come to the stage. Finally, we see somebody in person doing the presentation. Good.
Okay, thanks. Yes, so welcome everybody. Also online people, welcome to my presentation. I will give a presentation on distribution of peatland and organic soils in the Baltic Sea region, gaps and knowledge and challenges for climate change mitigation. My name is Andreas Haberl. I work for Succow Foundation, partner in the Greifswald Mire Centre, and we are also partner in the project. So if we have a look on peatland use in Europe, so peatlands are mainly drained and used for agriculture, forestry, and peat extraction in Europe. And here you can see in these pie charts that the north and the northeast of Europe contains large peatland areas, and a lot of peatlands are used there for forestry, agriculture, and peat extraction. And this causes emissions. So we know that from all drained peatlands, Europe is the second largest emitter of greenhouse gases. It makes 7% of EU's annual greenhouse gas emissions stem from drained peatlands, adding up to 230 megatons of CO2 equivalents annually. And if you have a look on the agriculture sector, Jeva gave the overall figure for the EU already in her opening speech. We have 3% of the agricultural area is used on drained organic soils, and it contributes to a quarter of the emissions from the total agricultural sector. And if we have a look on the Baltic Sea littoral countries, so then it's even worse, the problem, because they have more peatlands and more peatlands under drainage, and also more peatlands in the agricultural sector under drainage. And here we have emissions amounting up to 29% to 71% of the agricultural total emissions, only from 4% to 7% of the production area. So, but there are also good news. So the gray part of the pie charts are still pristine mires. You may wonder why I show this picture then with the settlements. This is a view you can have when you come to Riga by airplane. You will see the Riga Bay and also the 2 rivers, they conjunct there, so the Lilupe and the Daugava. And you have the pristine peatlands, coastal sea peatlands, and you see that there are also settlements, and you can see there is also for the infrastructure and for settlements you have to adapt and you have to drain to continue with your things you want to do there. Yeah. So, but this is also causing problems. And so we need to protect what is left and what is intact to avoid future high emissions. And we need to re-wet drain sites as far as we can do to reduce the emissions from that sites. So I asked colleagues from the Global Peatland Database, can you provide a map for the Baltic Sea littoral countries and the peatland distribution there? So they compiled all the data they have at the moment on their table and created this nice map with the Baltic Sea littoral countries. And they use a landscape approach when they have a look and check the data sets they have on the table. So because they say geomorphology, topography, hydrology, and climate determine the occurrence of peatlands. Because all peatlands have formed as mires in landscapes, even they have formed landscapes. Yeah? And you have to understand it's dependent on climate and on soil condition, on the topography, and then you will identify where peatlands can be located in the landscape. There's a nice publication, Mires and Peatlands of Europe, and there you find 10 Mire regions and 51 subregions where you can distinguish the differences by having a look on climate differences, having a look on topographical differences. And if you integrate that, you'll have a complete different view on where could be peatlands and where could they be, even if we have changed our environment dramatically. So, but also to give you some nice impressions. So we have also a high Mire biodiversity, Mire diversity in Europe, and also in the Baltic Sea region. So in the north, you have things like Palser mires. So this is related to permafrost and ice. So in this little heap of peat, you find an ice lens that even stays in summer because it's isolated by the peat on top. And you have large fen peatlands in the northern region. Yeah? These Mire complexes where you can see how the water flows and creates patterns on landscape level. Yeah? Beautiful pictures you can observe there from the bird perspectives. And you have, of course, these typical bog peatlands, like this one in Estonia. It's not the most pristine, it's close to Tallinn, but you can go there with the public transport and you have a really nice impression how these bog systems look like. And you can walk through and you find, even in dry summers, you find this nice, wet and relaxing landscapes. Or also in Latvia, we have also these bogs, typical bog region peatlands. Or in Lithuania, this raised bog is a very nice landscape. You'll be there and that you have this wide horizon, you have a completely different perspective on landscapes if you walk through such peatlands. And we find them also in the Atlantic bog region. You find also raised bog systems. They have a different vegetation composition, so you find more cotton grass there, even more cotton grass in Denmark. And we have also the continental fen and bog region where we have vast fen peatlands in river valleys. And this nice Lithuanian peatland, Čepkeliai, it has not only fen peatlands, but it has also bog systems in the fen complex system. So very nice and complex systems forming in landscapes, forming the landscape itself. And we have also nice examples in Germany. So this is how this is a restored peatland site. So it's a river valley peatland. And you can see also from the vegetation here, the complexity of landscape, because this brown species is dependent on calcareous rich waters. Yeah, it's Juncus subnodulosus. And you can see here that there is groundwater coming up, calcareous rich. And then when it promotes to the river in the center of the valley, you get rid of your calcareous contents in the water, and then you have a change in vegetation. So you can identify from the composition of vegetation and patterns, you can trace back to the properties of water and soil. So coming back to the figures behind the map. So from this map, we can add on all the peatland area, and we have approximately 225,000 square kilometers of total peatland area in the EU Baltic Sea littoral states. So this is the baseline for this map. Unfortunately, we have not distinguished the sectoral things. So these are the 61% of drained and degraded peatlands from the different sectors. This is from data from 22, but this is also what was the national inventory of 21 that was included in the 22 data. But what we can see, the overall picture of the total peatland area keeps quite stable if we compare the data set from 22 with the data set from 24. So the overall great picture we know, and it is quite stable. And if we have a closer look and compare the peatland for agriculture, forestry, and peat extraction in the Baltic Sea countries between 22 and 21 national inventory data and 23 national inventory data, we see also here the picture stays quite stable. So there are some changes, yeah. You may, and it's of course it's not very little, because we have here square kilometers, and it's in the order of 10,000 of square kilometers. It can differ, but the general overall picture stays quite stable. So the general picture is clear, and we know where we can start and where we need to start. But people always come, decision makers are insecure. Why are there so many inconsistencies between these inventories, between the maps you have? And we have different reasons for that. So we have differences in modeling and strategic focus. So sometimes we have incomplete model training data. Yeah, we have old data where people really went out into the peatlands, cored, and said, okay, we know how much peat there is. So there's a lack of field and ground truth data to train your models. We have activity data bias. Yeah? So sectors have a different view on their resources. Yeah, if you come from a peat extraction company, you're just interested in white peat if you want to produce horticultural substrates, and then you just map, of course, the exploitable resources you want to have in future your business running. So you neglect other parts that are also peatlands and have a special focus. So that leads to also to sectoral differences in cadasters and definitions. And you have administrative expert knowledge gaps. Yeah? There's often, if you have people sitting on a desk making strategic planning, they have a lack of ecosystem understanding. So there's a technocratic approach and focus often. And so you need more of consultants in ecosystem understanding and ecosystem functioning to get good strategic planning. And you have administrative restrictions. There are bureaucratic procedures, for example, the UNFCCC or the EU regulations, that it's a corset to keep working. But you have then also, you are not very flexible in integrating nature things, because nature is a living thing. It's not on paper. And of course, then you have political strategies and programs, and that you have conflicting priority settings. Do I have to keep working places in the countryside, or do I have to revamp because of the ecological good? The way out is a lot of communication, and of course we need ground truthing in the end. We need to go out and have a look. Is peat left, or is the peat already gone? We have trained it for several years, so it might be gone. There might be something left. We need to test it to, in future, further give best updates on our knowledge. To give you some examples, so this is a map in southeast Latvia, and we see here two inventories. So one is from a peat association in Latvia. In yellow, you find here quite large patches. This is what I said. This is some kind of these sectoral bias. They might have a focus on exploitable resources, and so they have large concrete patches. And the red ones, they are modeled by our colleague. He's also here, by Yanis Ivanovs, and he integrated hydrology models, so depths of water and how and geomorphological data, so the topography of as a very important component of this model. And he had a lot of training data sets from the forest inventory, so 15,000, Yanis, I think. You can join also later in a poster session at his poster, and because it's really an interesting model. But of course, then you get difference between these inventories. But GPT likes to include also, because we have a lot of information in these peat resource inventories, because they exactly know, they core deeper to know how much peat there is really to be exploited. And Yanis and the forest inventory just focused on the first half meter, and he was restricted just to less than 20 centimeters or more than 20 centimeters. So this is Also a nice training set, but there is a gap in this training set also. But also direct in front of our door in Greifswald, this is so the Greifswald Lagoon and the city of Greifswald. And we have nice peatland meadows just in front of our small town. And even so we have this year also 205th anniversary of this guy, Caspar David Friedrich, a famous artist of the Romantic period. And he painted this nice view of Greifswald, and he catched also this nice and wide peatland meadows there. But if you have a look on this map, so this is a map comparing what we from the Greifswald peatland database have is the green. And the green color indicates the where we overlap and have the same ideas on the peatland distribution as Thunen Institute. Thunen Institute does the National Inventory Report and gets all the data from the federal states, from the administrations of the federal states. And you see, so blue is Thunen, green we overlap, and red is data which only we in Greifswald Mire Centre and the Global Peatland Database have. So there are differences, and it's not nothing on this map. So these are quite huge red patches you see there, but we know at this cases, we know where they stem from. So because you have persons working also, yeah, and there you have animosities between persons. So this was a guy who mapped these coastal peatlands, but he was neglected from the administrative bodies. So they had some quarrels or whatever. So it was neglected and dropped out of the national inventory. So Thunen got not the information. But we, of course, we had students going there and having the diploma thesis or master thesis, and we know, okay, there must be some peatlands. We have some of them had been revetted already. There had been revetting projects. Yeah. But so then this is why you can get wrong ideas about what's out there. So conclusions. There is no universal and best map. Map is always a model. But we know already enough to act. Yeah, we don't need to wait for the best map and the next map, so we know where we can start and what we need to do. But inconsistencies should make us aware and stimulate exchange and improvement. So we can improve, but we can start acting and improve in future. And inclusion of groundwater models and topographical data improves maps. And to improve modeling more and up to date, and we need up-to-date and on-ground training plots. So we need really to go out and check if there is what is left or what is there. For those who are interested, so these are the references for the map. So this is all the data that was used for this map. And to conclude, peatlands must be wet. And if you want to learn more about paludiculture, it's a nice term. We have a nice poster at the poster session. You're welcome to join our poster, and we have nice discussions there. Thank you.
Thank you, Andres. When I will be asked today, how was the day? I would say I learned something new. Peatlands must be wet. I mean, nice slogan to start with. Okay, so we have a bunch of questions that came in through Slido. Well, obviously we can't see them from here, but I can read them. Okay, so this is a nice one. If you could suggest with immediate acceptance one thing to the Ministry of Agriculture in Latvia, what would it be?
With immediate acceptance?
With immediate acceptance. Like you have all the power in that ministry, so what it is.
And, yes. So what I would recommend is to have a complete revision of our water management, because agriculture needs water. As forestry, as we all need water to survive, and we need to have water be kept in the landscapes. At the moment, our system is like we leave all the water out of the landscape in spring, all goes down to the sea, and in dry summers it's needed. Yeah? And even so, also in the Baltics, we had dry summers and drought periods where we have really problems in agriculture to have harvests. Yeah? So my direct recommendation would be change water management drastically.
Drastically. Okay, we don't do drastic things in Latvia. We talk about them mostly. Okay, so You showed some examples from Germany. So what's the overall progress with peatland revetting in Germany?
So Germany has a lot of challenges to face, yeah, and we are not wide. No, we have not reached a lot of targets, but we are on a way. And yeah, we also have a lot of debates. So also there is drastic things have need debates and of course negotiations. And sometimes you step 3 steps ahead and 2 steps back, but slowly progressing.
Yeah, sounds like moving onwards. Okay, so how do you anticipate climate change would affect the distribution and health of peatlands and organic soils in the Baltic Sea region in coming decades?
So what we see from modeling is that we will have a different distribution of precipitation. Yeah, so we will have the more wet season will be in the winter season. Yeah. So there will be the most precipitation, the most rainfall, and in summer we will have more and more drought periods. Sometimes we will also have very wet summers, like we now face in southern Germany. We have high floods everywhere, but we will have more extremes. So I come back to the catchment area. So we need to reorganize our land use in the catchment areas, that we wisely use the water resources, and then we would not. Also, the peatland will do well in future. It's also good if you have enough water in the landscape that we hold back. Then also peatlands will benefit from that in future. If we don't organize it like that, peatlands will suffer, of course, and also pristine peatlands will degrade because there's in these drought periods not enough water to sustain them.
All right. Somebody asks for your recommendation. How to manage uncertainty of the emission projections in revetting projects implemented under voluntary carbon trading platforms?
Yes, this is a question of monitoring, of course. Yeah? You need to monitor what you do there and what is the impact on the emission characteristics. And this is why, so we have some standards that are very complex. So you have this verified carbon standard for peatland restoration projects. But yeah, it's very complicated because you have to set up a decent monitoring and you have to save a lot of the credits you produce and say this is for the uncertainty. Yeah? I don't sell them, so I need a high buffer to hold back in case my measures do not work properly and my monitoring gives a bad result. Then I have to need a buffer. So the answer is you need a sound monitoring scheme.
Okay, one last one. What specific conservation strategies do you recommend for implementing in pristine peatlands to avoid increase of gas emissions and loss of carbon? And how can these strategies be effectively implemented at both local and regional levels?
Please.
And we talk about Baltic Sea region.
Please give me the start of the question.
Yeah, specific conservation strategies.
In pristine peatlands?
Yes. Oh. Do you like this one?
I don't know. I don't know if I really understand it.
We can always skip this. I mean,
but for pristine peatlands, of course, pristine peatlands need water, and this comes back to my answer I gave before. Yeah, so we need to have an eye on catchments, and because if we have just a small conservation area and we fumble around there in managing the water level there and neglect the landscape around it, it will not work out. We need water in the landscape, and then also the peatlands will do well.
Okay. We have a tradition. When I say one last one, we always have one other one. Okay. So here's a question you can read. So it's.
So is paludiculture an option, or do I see it as a perspective? Yes, I see it as a perspective. It is a perspective, and it is not more than a perspective, because for the climate, we could just revet peatlands and then it's done. Yeah, so then we would be fine. But of course, we need to give people a perspective. Yeah? And if there is a land owner and a land user, and he can make money from wet cultivation of peatlands, yeah, then he's in the boat. If you just frustrate him and say, yeah, we revet now your land, and then you can see where you are, then of course he's frustrated and he will oppose. So it's a tool to get people into your boat and row also for peatland revetting. Okay. Yeah.
All right. Thanks so much. Well done, Andreas. Thank you.